So we had to remember always do the last thing first, but what about this one? This was something that we had to remember. Yes, my friend. Yep. Yeah, this would be the same as x plus 7 all over 4, and then it's an easier question to solve. Okay, so that was little ones that we have to sort of remember. Then we looked at expanding brackets. And we had to remember that when we expand brackets, it's just the thing out the front here. So are we going to go 4 take 3 first? No, 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 no. Because order of operations, we have to do the times first. So we keep the 4 underneath, and then we expand the brackets. Minus 3 times 2 is minus 6. What's a negative times a positive? A negative. Gather your like terms. The whole plan, Carolyn, is to have your x's on one side, non-x's on the other, right? And away we go. Were there any questions from that for homework? Question 1, question 2. Speak now, forever hold your peace. Can't do anything with the 5 and the minus x. Carol, are you with us? So we just keep the 5 and the minus x underneath, but we can expand our bracket. So we're going to expand through. Minus 2 times x is minus 2x. And minus 2, a minus times a positive is a minus. Take 6 equals x plus 4. What is our game plan? What is the whole point that we're trying to do here? Yep.
Solve x.
We're trying to solve for x, but in order to do that, what's our plan of attack? Like, you've got to have a game plan.
Get rid of the x's on one side.
Excellent. So we want our x's on one side, and we want things without an x, so just the constant terms on the other side. Now, you could do it all in one hit. I like to do a little bit at a time. It's early in the week, but I'm still knackered. So I'm going to gather my like terms. Minus x, take 2x. How many x's have I got? No, I give you 1. I give you another 2. How much? I have given you 3x. And then I've got 5, take 6. So again, looking at the signs in front. So I've got a positive 5, take 6, that's minus 1. So as we are getting practice with our positives and negatives, I strongly suggest try and just do one thing at a time rather than put everything on one side on it. So now we get to move. I think you like to have your x's on the one side, so this x here has to come over. We have to remove it from the right-hand side. How do I remove it?
Minus 4.
I want to remove the x. I'm going to minus x, that's right. So 3 minus 3x, take x, right? This x has gone from that side, agreed? What's left on this side?
4.
The 4. I don't have to put the plus in front because we just assume. Carolyn, I don't want this minus 1 here. It's out of its depth. I want to get rid of this minus 1 and pop it on the other side. So how do I get rid of the take 1? Absolutely, plus 1. So now we've got minus 4x. 4 plus 1 is 5. How do I get rid of the times negative 4? Divide by negative 4. And we write that as a fraction. Now, technically, you could write 5 divided by negative 4, but that looks a bit funky. So I would say negative 5 over 4. They all mean the same thing. Happy to start I? All right, so we've got the 3. We've got the take 4. And why am I messing around and putting that there? Because I can't do anything with it. But this, and I can guarantee you, right? I'm guaranteeing you right now, this is one of my all-time favourite questions to put, and there is one like this in your assignment. Only because I just want you to realise here, when you've got the minus, what you are doing is you are minusing the x, and you are minusing that 5. You're taking away both of them. If you don't like that, think about it, that's technically a minus 1 there. Now, you were all happy to do it when we had the minus 2 in front. Same thing. What's minus 1 times x? Minus x. What's negative times a positive?
Negative.
Negative. So you're either looking at it as minus 1, you're timesing through, or you're going take x, take 5. Same deal.
You're just putting negatives in front of all those numbers.
Yep. And of course, if that was minus 5 there, what's a negative and a negative?
Positive.
Correct. But for some reason, when there isn't a number there, all of a sudden we want to go, oh, what's happening? What's happening? Same thing. Same thing. So we're going to tidy up the left-hand side. Notice I like to do my x's first. So what is minus 4x? Take another x.
Minus 5x.
Minus 5x. Then we do our constant terms. What would that be? I heard that, negative 2, correct? Right, I don't want my take 2. How do I get rid of a take 2?
Plus 2.
Now, if you are still a little bit shaky with your negatives, you're writing that. If you are not shaky with your positives and negatives, you could have gone straight to that line. Okay? And of course, minus 5 times what gives you minus 5? Not negative 1. Yeah, if you said negative, a negative times a negative is a positive. Okay? So x is 1. Up to you. I see some students still do that, and that's fine. If that's you're just in the groove and you do it all the time, go forth. So how we... Funky, Cole Medina, it's a song. 3 times 2x is 6x. 3 times minus 5 is minus 15. We've got a plus 10. We've got 6x, take 5. We tidy up on the left-hand side. We've got 6x minus 15 plus 10 is minus 5. Equals 6x plus take 5, and you go, huh, what happens here? How do I get rid of, Jess, have you done this? So, what you can see is things will cancel out. How do I get rid of the 6x? You take 6x, what's 6x take 6x? Nothing. Get rid of the take 5, you add 5. And so what this is actually saying, and again, I'm explaining, I haven't got people watching, is you could put any number in here for x, any number whatsoever, and this would be true because everything is cancelling out. So this one, I would say this x can be any number, and remember we've said that mathematicians do not like writing too much.
Upside down triangle sense.
It's this. So I don't know from yesterday if you remember, one of the things we saw was this funny epsilon. This is an element of all real numbers. And if you're thinking, what does real numbers mean? They're the numbers you have. My year 12s at the moment, we're playing with imaginary numbers.
Isn't there like no such thing as a negative number? Or like no, 0 is not an actual number?
No.
Yeah, 0 is a number.
Now, what happens though if you had this? What happens if you had 6x, I don't know why you're talking at the back there. What happens if you had, oh, come on. If you had 6x take 5 equals 6x plus 5. What's going on now?
They wouldn't cancel each other out.
They wouldn't. So get rid of the 6x. What's 6x take 6x? We get 0. How do I get rid of a take 5?
Plus 5.
So, if it was different, all right, get rid of the 6x, take 6x, take 6x, no x. How do I get rid of a take 5, you plus 5? We end up with 0 equals 10. Is that possible? No. So what happens when you get down to something like that? What we're saying is there is no possible value for x that you could come up with that you could sub into the equation that would solve it. Right? Geometrically, what is going on here is it can also be, when you've got two sides of an equation, is what is happening is it can be, we've got one line, right? One side of the equation represents a line. The other side represents another line. So they can meet how many times? Once, because they're straight lines. So now I want you to think graphically, what is this when it has no solution? What does that look like if it's the two lines? They are parallel. Absolutely. We have two parallel, no solution, they will never meet. What does this one look like if you've got infinitely many solutions? They meet all the time.
They're one line.
They're on top of each other. That's actually called coincident, right? So if you've got that happening, you've got infinitely many solutions. Sweet. So all parts of maths are sort of connected because later on we're actually going to look at the graphical part of this. Yep.
in B.
Now, you think because fractions are involved, it's going to be harder. Niet. You are still looking at what you don't like, possibly. Maybe you like fractions, right? What we don't like, we want to get rid of it. So for starters, what is happening to x here?
It's getting divided by 2.
So it's getting divided by 2. So how do I undo a divide by 2?
Times by 2.
And that is exactly what we do. So we would now say x equals the other side. It just happens to be a fraction, but the rules do not change. 10 over 9. Done? Back to the days of equivalent fractions. Gave you a bit of a clue there.
Oh, because it's a 10, you want to get them both the same, and whatever you do to the bottom number, you have to do to the top number.
Oh, I wish I was quicker. Here you go.
So you get 1.
Because it's they're both different. You want to get them both the same. So it's what you did to the bottom one to get 10 on 10, you do to the top one.
Right. So what did we times 5 by to get to the 10? We times by 2. What I do to the bottom? I have to do the top. So we have to times the whole thing, and we use brackets. Now the more that you do of this, you realise what's going on with the denominators. Are they actually useful in any way, shape or form? No, because you cannot have the situation of 3/10 equals 7/10. That's just impossible, right? So if this number of tenths equals that number, can't we then say that this is then true? Absolutely. It has to be. This tenths equals this tenths. The tops have to equal each other. If that was like 101, well then we couldn't say it because they're different denominators, but for sure. Okay? And now this becomes like question 2. So we're going to expand the brackets. 2x take 2 equals x. Can we solve for x? Yeah? Tell me, what am I going to do? I'm going to rock the boat a little bit. Watch what I do. Finn, are you right? You must look angry. Come here. So, watching. What can I do here? Please just look and tell me if I have done something wrong. Move. I don't know what this is. Go away. Oh well. I know. I would think everybody would have done it a different way. Because don't you all like to have your x's on the left-hand side? Fair enough. So you do that. 2x take 1x is x. How do I get rid of the take 2? Add 2. No good doing it the long way, but you see, you get the same answer. Sometimes it's actually better to go the right-hand side. This time it was nice because it was just a single one. But anyway, ignore me. All right, last one. What are we going to do here? What's a number that 3 and 2 both go into?
6.
So what do I have to times 3 by to get to 6?
2.
2. And what do I have to times 2 by to get to 3?
3.
So this is a situation when technically we can go, okay, I'm saying I want it over 6. So I'm going to have to times that one by 3. I'm going to have to times this one by 2. Yeah? So we're now left with 2x equals 3x plus 1. We get a little bit sloppy in maths, which is allowed, believe it or not, and you can do this thing called cross-multiplying. So you can jump straight to this step. 2 times x is 2x, 3 times x plus 1, bang.
What do you mean by that?
I mean exactly what I just said. You can cross-multiply. What did I have to times 3 by to get to 6? 2. It's the other one. You could have done that here, but you're going 10 times 5, and that's making your common denominator 50, and it's too much. So it's better if you've got a lowest common denominator, rock with that. Okay? Doesn't come out very well, does it? That's a plus. Is that a take? Yes, take. Okay. Shh.
20.
Yep. So your lowest common denominator here is 20. So what did you times 5 by to get to 20? 4. So in effect, once again, we are cross multiplying. So I'm going to start being a little bit, I guess, lazy. Okay, so to get the 5 to 20, we times by 4. What I do to the bottom, I do to the top. To get the 4 to 20, we times by 5. Same thing I do to the top. Want to come on down? You're laughing? It's so simple. Come on down. Do it on the board. Yep, that's why it's called cross multiplying, because you. Right? And as I said, you can do the cross multiplying here, but too crazy because you've got such big numbers, right? You could go the lower numbers. Yeah. Expand the brackets. So we just had a question, could we have done cross multiplication with the other questions? Now, I thought we had just said that, like this one, you could have, but because you're going 10 and 5, that would give you the common denominator of 50. You'd still end up with the same answer, right? But you're using much bigger numbers. In fact, why don't I just do that? So if I did this, this would be 10, x take 1 equals 5x. So that gives me 10x take 10 equals 5x. Bring the 5 over, so that becomes 5x equals 10. How do I get rid of a times 5? Divide by 5. 10 divided by 5 is 2. Now you get the same answer, you're just using bigger numbers. When we're talking about 5 and 10, we're probably going, oh, not a big deal. But if it's the difference between, I don't know, 4 and 16, maybe that becomes a harder question. So always try and look for the lowest common answer. But, yep, as a last resort, cross multiplying will work. Yes?